So thank you very much for having me. A special thank you to Pradeep for inviting me. This is some research that we have just completed about a topic which is becoming very, well, topical, I suppose, in the financial markets. So this is looking at the introduction of a speed bump into the Canadian market, which is definitely something that I know is of concern for SEBI and for India, as one of the recommendations that they have put forward as a proposal for something that they could do. And it's something that we're starting to see more of. So IEX brought in the first one, Canada has brought in the second one. We're now seeing proposals from NASDAQ and the Chicago Exchange to bring in various different kinds of incarnations of these speed bumps. And I guess one of the main takeaways of my paper is that it really depends on the construction of the speed bump as to who are the winners and the losers that you are choosing. And so this becomes something that's quite important. So what I'm going to do first, take you a bit through what is a speed bump, why we might need one, and how the IEX one has operated. And then I'm going to talk a bit more about what was brought in Canada. So as you know, the markets have moved to this real high kind of frequency. So you can get from, let me find one, I think we have one for Mumbai to London. You can get from Mumbai to London in 108 milliseconds. To give you a sense of scale, it takes you 300 milliseconds to blink your eyes. So the markets have become very, very fast, or how we interact between market centers has become very fast. And we also have a lot of fragmentation. Now, I know it's not the case in India that you don't have fragmentation, but the rest of the world, in Australia, in Canada, in the US, we have a lot of fragmentation. In Canada, they have about 8 different stock exchanges trading the same things. And in the US, they have almost over 40. In Australia, we have just 2. But you get this fragmentation, and fragmentation creates a problem. So you have a trader, and the trader, I should not walk in front of that. The trader would like to access, let's say in this case, he wants to buy. So we have on the left side the bids, in the blue, there are the asks. So he wants to buy, let's say for $10.10, all of the liquidity that's available. And there are 6, let's say, 1,000 shares that are available across these 3 various exchanges. So what does he do? Well, he creates 3 orders. He sends them to those 3 different exchanges. But he may face a problem. The problem that he may face is that the markets are very fast, and all of his orders are unlikely to arrive at identical times. So what he needs to do is he needs to try to figure out how to get them there, maybe all at the same time. That would be useful. But he faces some random latency in the market, in the environment. He doesn't know exactly how the internet will take his messages. So one of the problems that he may face is that he may trade, let's say on the Toronto Stock Exchange, he will trade all of the 3,000 shares that are available. He wants to trade those remaining 3,000 shares split across 2 other venues. But before he can do so, a high-frequency trader, let's say somebody may be using microwave links, will be able to race him back to the other exchanges and cancel those orders that were sitting there. Now, you can see the microwave, the HFTs in my computer, and then the green are the 2 canceled orders. So if he cancels them, we have a problem, or the trader has a problem. The trader's problem is that he didn't get filled, right? He wanted to buy 6,000. He was only able to buy 3,000. Now he has a problem. The second problem he may face is that if he really does need to trade all of those 6,000 shares, instead of paying $10.10 for 6,000, he pays $10.10 for 3,000, ends up paying an extra 1 cent times 3,000 shares. Maybe it's only $30. You think, well, it's not a big deal. He's only paying extra $30. Well, but if he's paying extra $30, then that's some rents that the high-frequency trader is able to capture. And that high-frequency trader can use those rents to pay for example, his nice, shiny microwave tower. So, what is the potential solution? Well, IEX proposed a potential solution in the US, so they introduced it, and it's been approved as an exchange now. So one of the things they said is, okay, what we're going to do, we're going to create a little shoebox. The little shoebox will have 10 kilometers of fiber optic cable inside. And every order that comes in, it will go to the shoebox first, it will run around, and then get spat out. And this will induce a delay of 350 microseconds. This is less than 1 millisecond. Remember, it takes 300 milliseconds to blink your eyes. So this is a very, very small kind of delay that they're introducing here. Now, the idea is like this. Me and my fiance, we were in Cuba, and we both sent postcards to our parents. Her parents live in Russia, my parents live in Australia. And when we sent the postcard to Australia, it took 3 weeks to get there. The postcard to Russia took 6 weeks. Okay, the Russian postal system, maybe it's not the best. Now, if we had some very sensitive information, let's say that we were announcing our wedding, and we don't want my dad to get the card, call to her mom and say, oh, congratulations. He said, congratulations on what? Right? Well, then what could we do? What we could do is we could send the postcard to Australia or to Russia first, and then 3 weeks later, we send the postcard to Australia. Then we know that they should arrive at the same time, right? So that's exactly what the idea of this delay, this speed bump, was designed for. So if I know that my order will be held for 350 microseconds, or let's say 1 millisecond, what I could do is I could send the order to that venue 1 millisecond before I send the order to the other venue. Now, if the trader sees, let's see if this is going to work, if the trader sees, or the high-frequency trader sees that this execution has happened here, he's going to send in an order to race me to here. But he cannot race me because I sent that postcard first. I sent that order first, so it will already be in the shoebox. So now he'll send his cancel, but his cancel will be behind me by construction. So it gives me a mechanism to protect myself. This is the story of Flash Boys. If you read this very famous Michael Lewis book, this is the story of Flash Boys, and he says, okay, well, this is very beneficial because it helps the traders to access some liquidity that, and avoid this kind of speed game so they don't have to engage in such, expensive microwave technology, for example. So then we come to the experiment in Canada. So the experiment in Canada was a little bit different. So it only occurred just about 1 year ago. And they introduced, instead of a shoebox, which is hardware, right? They introduced the delay in software. So they introduced a randomized delay. This is going to become important. So they said, okay, the delay is going to be between 1 and 3 milliseconds, maybe a continuous distribution, could be 2.2 or 1.8 or whatever. And they said that this randomized delay will apply for every order type except for post-only orders. So then I hear you ask, okay, well, what is a post-only order? Well, a post-only order is an order which will not remove liquidity. So it's kind of like a limit order. I want to make sure that I'm going to be providing liquidity. If that order could become a market order because the state of the market had changed, then it will just cancel. Sort of like the opposite of a fill or kill, if you're familiar with those. So they also inverted the maker-taker pricing. So they started to charge the people who were providing liquidity instead of giving them a rebate. So if I'm going to take liquidity, then they're going to pay me. And if I'm going to supply liquidity, I have to pay. You might think, hang on, but I'm offering a limit order. It's like an option. Why do I want to pay to provide the options? Okay, well, we'll get there. So what did the industry say? Industry said, we think it's going to be very bad. One of the things that I know India is very concerned about right now is this idea of fleeting liquidity, right? The cancellations, that people are canceling so many orders they never actually intended to trade. Okay, well, this is what I'm going to try to measure, and this is actually what the marketplace said. They said that this post-only resting orders will have the ability to fade once they see trading on another venue. They said the introduction of speed bumps is going to make it more difficult to access liquidity at depth and aggregate quote fade across marketplaces. They said often shares will be withdrawn from the market as soon as the order begins to execute. So it seems like when I presented this to the Securities Commission of Ontario of Canada, the commissioner asked me, well, Sean, was this something that was foreseeable? I said, well, I want to be very kind. So I said, okay, well, nobody tried it before. So it's very difficult to say what would happen, but I cannot hide the fact that many of the participants in the market did seem to understand what would be the result of introducing this kind of feature. So I do a regular kind of event study, and I had to build some new measures. So a lot of the techniques that we have, well, the toolbox of metrics that we have were not appropriate to measure what I'm trying to understand. So I will spare you the nitty-gritty construction because Susan only gave me 15 minutes, not 20 or 25. But basically, we tried to build a measure of quote fade. So we want to understand how frequently are orders being removed when you before you can access them, when you're trying to access them. Okay? So what was the impact of the speed bump? I think about a telescope, and a telescope's point is to let you see things that are very small that you cannot otherwise see, right? And so when I think about the telescopes that I use, they're different perhaps from the legal profession that we've been hearing about. I use a thing like a regression, right? I use a regression and it helps me to identify, disentangle the effects. Okay, but you know what you don't need a telescope for? You don't need a telescope to see a solar eclipse. It is so strong that you can say, oh, well, hey, what happened to the sun? So I really like this paper because I don't need to show you any regressions. I can just show you pictures. The effects are so strong. So what I did, I looked for a few of the different venues, the 4 major venues in Canada. I constructed this measure of quote fade. So this is what proportion of orders left, ran away before I could access them when I was trying to access them. So what you can see is that previously, maybe on the TSX, the biggest exchange, Toronto Exchange, maybe 15, 20% of orders ran away before you could grab them. On the other venues, they're all a bit smaller, so there may be about 30%. And that seems quite stable across this. Actually, I did it for 1 year before and 1 year after. A lot of data to crunch, right? But what you see for alpha is that as soon as the regulation, the change in the market structure comes in, suddenly 70 to 80% of the shares that I saw run away from me before I can trade them when I try to trade them. So what does this mean? This means if there were 10,000 shares sitting there and I send an order to try to get them, 8,000 of them are going to disappear. I only end up getting 2,000 of them. So it's becoming very difficult for me to access the liquidity that I think I can see. Those orders just run away. So we did some other tests. We wanted to see, okay, well, who is taking the liquidity? So remember, they changed the way that you pay. So you pay to post. We say, well, why do I want to pay to post? Well, if you think about the spread that a market maker is earning, one of the components is, one of the costs that he needs to cover is the order processing cost. That is the cost of paying the exchange. But another component that they need to cover is adverse selection. So this is the cost of trading with someone who's more informed than me. Now, the people who are likely to be very uninformed are retail traders in general. They are not trading big packages of shares. They're just trading a small amount. So we see a significant increase in the amount of retail traders who are accessing liquidity on this venue. We wanted to think, okay, well, who's paying to access this? Remember, you get 1 to 3 milliseconds to get out of the way. Well, it took you 300 milliseconds to blink your eyes. This is not a person. This can only be a computer. So I start seeing trading on the other venues. I say, hey, gee, somebody's going to come and hit me soon. I'm going to cancel. Okay? So, well, who's going to benefit from that? Well, it must be high-frequency traders. And if we look at the high-frequency traders, the red line here, there's a significant increase in the liquidity provision by high-frequency traders. Other guys, they don't want to play in this field. We split it up. We built some new metrics to consider if the trade got rid of all of the available liquidity, so it looks more like an institution, and if the trade accessed multiple different venues or only one. And so the idea being that a retail trade would look like maybe just go to one venue, doesn't exhaust all of the liquidity. And so we see that that's this kind of red line at the top. That was about 50% of trading previously, drops to like 20. So it seems that the institutional guys, they're not able to access liquidity here anymore. The retail guys, the small red line, they go from 20 to 50. So it seems that the institutions are not able to access this liquidity anymore. Well, why not? Maybe they didn't go there, or maybe the quotes faded. Well, already I showed you that the quotes are fading. So I know why they're not trading there, because they can't trade there. They try to trade there, and the liquidity runs away from them. So we also looked at the fees that the market makers are earning. We find that the realized spreads that they're earning used to be somewhere around maybe 0.1 cents. Suddenly they're increasing significantly, but only on alpha. So they're earning a lot more money because they can avoid trading with the informed institutions, only trade with the retail guys. But then you can say, okay, well, what's the impact on the overall Canadian market? Maybe some guys are getting maybe a better deal. The retail guys, maybe they're getting a better deal. Actually, they're not. I don't have enough slides or time to show you my slides, but they're not. So then you say, okay, well, maybe is it bad for the rest of Canada? You just took the retail guys, you put them over here, and you left everybody else together. Well, it's kind of like if you have a fish tank full of sharks, right? All the sharks, they're going to eat each other. If you have little fish, the sharks just eat the little fish. So we looked, I did do a regression for this one, and sorry, it's a bit small, but what I can tell you is that the effective spread increases on all of the other venues, right? It becomes more costly to trade on all of the other venues except for that one. The market makers, they earn a lot less on all of those other venues except for alpha, right? Alpha goes up, but the rest of the market comes down. We see increases in adverse selection costs across all of those venues. We can also look at, for example, the quoted spread for the whole market. I put it into a big pot. Let's not look by venue, one venue by one venue. Let's look for the whole market. We find the quoted spread for the whole market increased by 35 to 60 basis points. Now, when I presented this to the commissioner of the Ontario Securities Commission, she said, if I take 60 basis points and multiply by all the trading in Canada, It's probably a big number, isn't it? I said, yeah, about $105 million. I said, we maybe shouldn't have approved that, should we? I said, well, I don't know. But it's a very big regulator who looks at the evidence and says, okay, maybe we made a rule change, but now we need to reassess and think about, well, do we want to maintain this? Let's see, I think that's it. Yeah, so I guess the conclusion is there are multiple different types of speed bumps. So I wrote a letter of support, for example, based on my research to the SEC for the IEX speed bump, because I think that one gives people a valid opportunity to avoid high-frequency front-running. The kind of speed bump that was brought in, because it was randomized, potentially, and because you could pay more to avoid having to experience the speed bump. Because they had these two differences to the IEX one, the IEX one applied to everyone equally. But those post-only orders, I can pay more to have my order not experienced, to cancel my order with no delay, right? So you give not a fair playing field. You give some participants the ability to cancel with no delay if they pay more. And you give a randomization, which means I don't know how early I should send my postcard to Russia or to Australia. So I think it's very important that we consider how a speed bump is constructed before we implement it and what the impacts of those differences will be. And so if you look at the Chicago Stock Exchange, it's sort of halfway between. It applies to everyone, but it's randomized. Okay, well, here's a new study. Look at all the different speed bumps and see what impacts they've had. That's it. Thanks, guys.